In this video, we're going to do example 9. There's a few different methods that you can use to do it. I'm going to walk you through at least one of the methods, and the other method you can try to figure out yourself. You can look at the slide to figure it out, and then you might even come up with your own other method to solve this type of problem. So we want to calculate the molar concentration of 24% mass solution of hydrochloric acid, and we know the density of the hydrochloric acid is 1.13 grams per mil. So I'm just going to call this method 1 over here. And in method 1, what I'm going to do is I'm going to basically assume 100 grams of solution. And so what that means is that since I made that assumption, therefore I have 24 grams of hydrochloric acid. And remember, just a reminder here, that we want to find the concentration as a molar concentration. So C is equal to N over V. Now, if I have 24 grams of HCl, I can find my moles, because moles is equal to, so mass is equal to moles times molar mass. Therefore, moles is equal to mass over molar mass, which is the 24 grams over, and the reason that works is if I have 100 grams and it's 24% mass, that means that my solute, which is HCl, must be 24 grams. Over the HCl, which is 35.45 plus 1.01, gives us 36.46 grams per mole. So 24 divided by that answer gives us about 0.658255622 moles. So we have our moles now. That's a 658 there, by the way. So let's erase that and make sure we can write it so it's legible. We need our volume. So we know our mass. We said assume 100 grams. So since we're assuming 100 grams, we can find the volume because we know we have our density. Remember, density is mass over volume. So if we want volume, we simply have to do volume is mass over density. So that means our volume is going to be equal to, we have mass of our solution, because this is the solution density. So mass of our solution is 100 grams over the density, which is 1.13 grams per mil. Cancel out grams and you get mils. So 100 divided by 1.13, and we get about 88.49, keeps going, 557522. 557522 milliliters, which is approximately, so in liters, you divide that by 1,000, you get 0.088495575 liters. So what do? We assumed 100 grams, which means we have 24 grams of HCl since it's a 24% mass solution. So we found our moles. Now, if we assumed 100 grams of solution, we can find the volume because we know the density and the mass of the solution is 100 grams. So we can rearrange our density equation to find our volume there. Now we have to convert that to liters. Our final step is going to be to do our our C is equal to N over V, which is equal to the 0.658 moles divided by our 0.08849, so on and so forth, liters. All the digits are still in my calculator. So I have 0.658255622 divided by our answer there, and we get about 7.438288529 moles per liter, which is approximately, according to our sig figs, how many sig figs do we have? 2 sig figs, so about 7.4 moles per liter. So that's what the molar concentration of a 24% mass solution of hydrochloric acid would be. That would be method 1. There's a few other methods that you can do. I'll teach you one more method, and then you might be able to think of another method to solve this problem. So let's go ahead and do method 2. But they all work the same way. So for method 2, we're just going to straight up convert the 1.13 grams per mil into moles per liter. So 1.13 grams per mil into how many moles per liter? So we can essentially convert all of this one at a time. So let's start converting our 1.13 grams into moles. So for that part, we can do 1.13 grams divided by the molar mass. So our first part here, let's do that. So our first part is grams to mole. And we know that mole is equal to mass over molar mass, which is equal to the 1.13 grams over the 36.46 grams per mole. Cross that out and we get our mole value. So 1.13 divided by 36.46, and we get 0.030992868 moles. And now we can do our conversion for our volume. So here we have grams per mil. So 1 milliliter is equal to 0.001 liters, right? Because that's 1 divided by 1,000. So 0.001 liters. And now we can simply do our C is equal to N over V, which is going to be 0.030992868 moles over the 0.001 liters. So 0.030992868 divided by that. And we get 30.99288 moles per liter. Now you'll notice that the answers don't quite match up there. And that's because, remember that this is a 24% mass solution. So our final step could simply be to multiply this by 24%. So we get 0.24 times the 30.9928868 moles per liter, and we get 7.43828832 moles per liter, which is approximately to, in this case, since we're using only our 1.13 there, we're going to, actually the smallest number of sig figs is 2. So we're going to have 7.4 again moles per liter. And so that brings us back to the same answer that we got over here, just using a different method. We converted. So we just converted the 1.13 grams into moles. Now what I should have done is probably applied the 24% just earlier on, because we actually only have 24% of it by mass. And then afterwards use my, and then continued the rest from there. So I would have had one less step to do over here, essentially. So this should have been applied when I did my mass calculation, and then afterwards I would have been wouldn't have had to do step 4 because it was embedded in step 1. So that was essentially method 2, where we just converted each component of the density and multiplied by the 0.24. You could do it at the last step. You can embed it in the first step. It doesn't really matter. But that was a different method to get us to the same answer for a trickier question like this. There are other ways to do it. If you find other ways, make sure to share with your peers, and with your classmates, and with your teacher to verify if that method works. Essentially, if you get to this answer, you're on the right track, but try to think logically about why it works. Don't just try to plug in numbers and just say mathematically works. Try to figure out why that actually works out based on the strategy and based on the logic behind it.